All right, in this section, we're going to talk about lines, characteristics of lines, things to identify from a line, equations of lines, things like that. So this will be kind of a long video. Apologize ahead of time, but there are a lot of topics. First, we want to be able to identify the slope of a line, which is the measure of the steepness. We're going to be asked to identify the y-intercept of lines and pretty much of anything as we move in the course. And that's where the line crosses the y-axis. The x-coordinate is 0 for the y-intercept. And we also want to be able to identify the x-intercept of a line. And that's where the line crosses the x-axis. And in this case, the y-coordinate is 0. So to be an intercept, it must lie either on the x-axis or the y-axis. Now, when we talk about slope, it is the measure of steepness of a line. We often consider slope as rise over run. Okay, if you ever have done any roofing or things like that, it's often called the pitch. Okay, it's the vertical change in distance versus the horizontal change. Okay, so the rise is your change in your y-coordinate. The run is the change in the x-coordinate. M is the symbol for slope. So what we have is we can physically say the slope is rise over run by just counting, or we can use a formula. Instead of counting, we subtract the y-coordinates, put that over the difference in the x-coordinates. Okay, so, that's kind of, the deal there with these items. Now, there are 3 ways we can calculate the slope. We can find the slope from the line itself on a graph. We can find the slope from 2 points, and we can find the slope from an equation. Okay, so if we're given a line, and what we want to do is we want to physically count rise over run. Now, these, are coordinates here, 0, 3, and 4, 0, because I want to find points that I know for sure that, my number is on the, actual value. So this would be the y-intercept, this would be the x-intercept. But to find the slope, I start from any point on the line, and I do a rectangular down and over or up and over. So my rise would be down 3, right 4. So my slope is down 3, right 4. And the down movement is negative and right is positive. So my slope is negative 3/4, and that often, or not often, but will always be negative slope, will be your line kind of goes downhill. It decreases from left to right. So that's how you know you're correct with that. So you can do it from a graph. Now you could also have done, up 3, left 4, and that's okay because up is positive, left is negative. So you're still going to get an overall negative slope. So now let's look at finding slope given 2 points. So, my formula is y2 minus 1 over x2 minus x1. Now, these subscripts here just refer to the first y-coordinate, the second y-coordinate, first x-coordinate, second x-coordinate. So, I can say this is my first point, this is my second point, or I can say this is my first point, this is my second point. But if I choose this to be my first point, this is x1, y1. x2, y2. You can't interchange them. So, the normal way of doing things is to say this is the first, this is the second. So, therefore, I would do my difference in my y's. Be careful here, because we have negative 3 minus 2 over 5 minus 1. So that's going to be negative 5 over 4, and that would be my slope. So, we can use slope. We can not only calculate slope between points, but we can use the slope to plot additional points depending upon the equation we're given. So here's an example where we can find slope of various lines containing the same point. And it's just going to illustrate here the 4 different types of slope. So again, I use my same formula, and I take -2 minus 3 over -1 minus 2. And this would be -5 over -3, which actually is 5/3. So if you think about slope, you can have negative over negative, but that's also positive. Okay, so your positive slope, the line increases as you go left to right. Second line, I would take my -1 minus 3 over 3 minus 2, and I get -4 over 1, which is just -4. And this type of slope, the line would decrease. So a negative slope, the line goes downhill as we go left to right. The third line, I do my difference in my y's over my difference in my x's, and I get 0 slope. And 0 slope is a horizontal line. So you've got positive, negative, horizontal, and the fourth type will look like this, where you get 0 in the denominator, which is undefined, or no slope. I like to use undefined because sometimes people get no slope confused with 0 slope, but it is a vertical line. Okay, it's a vertical line. So those are your 4 types of slopes, and really your lines can only be positive. They can either go uphill, downhill, horizontal, or vertical. The third way we talked about finding slope is from an equation. So if your equation is in the form y equals mx plus b, we call that slope-intercept form, because what this format gives us is the slope and the y-intercept. So in this situation, the slope is m, the y-intercept is b. So for this particular equation here, the slope is 3, and the y-intercept is 0, -5. But we must put it in slope-intercept form before we can identify the slope and the y-intercept. So we must solve them for y. So if I take this equation here and I want to find the slope and y-intercept, I want to solve for y. So I want to get y by itself. So the first thing I'm going to do is I'm going to subtract 3x. When I do that, I get -5y is -3x plus the 9. And I list my x first just because I want it to look like the slope-intercept form here. Okay, I can't combine these two. Then I divide both sides by -5, and when I divide by -5, I distribute just like I do multiplication. So what I get is y, and I get -3 over -5x, and I get 9 over -5. So that double negative makes positive, and this ends up being -9/5. So my slope is 3/5, and my y-intercept is 0, -9/5. Okay, so if we are, putting equation in slope-intercept form, we can find the y-intercept. Now, if I want to find the y-intercept for equations not in slope-intercept form, well, remember, as I told you earlier, your x coordinate is 0. So I can find x and y anytime I want to and choose random numbers. So if I want to find the y-intercept, I choose 0 for x, substitute it in, and then find y. So in this case, I would put 0 in for x. That goes away. Divide by -5, and y is -2. So 0, -2 is my y-intercept. So remember, x coordinate is 0. While we're doing intercepts, we might as well do the x-intercept. So therefore, if the y-intercept is found by letting x be 0, the x-intercept is found by letting y be 0. So I choose 0 for y, substitute it, solve. So in this case, I put 0 in for y, and solve. So my x-intercept is 10/3 0. So make sure when you put things in point form, you put them in there correctly. I often see students getting intercepts backwards. Okay, x, y. So just keep that in mind. Okay, so that's kind of finding your intercepts. Now, we're going to come back to this when we do some more graphing, but there's ways we can graph linear equations. I basically look at two methods. If I'm going to make a table of values, oftentimes I'm just going to find the intercepts because 0's easier, okay, in most cases to substitute into equations. And if not, if the equation's in slope-intercept form, I'm going to use 1 point and the slope. So let's look at this equation. So I'm going to kind of illustrate what I'm talking about. So if I want to graph this equation, finding intercepts. Well, if you think about your XY table, what I'm doing here is I'm choosing 0 for X and I'm going to find Y. Choose 0 for Y and I'm going to find X, because to draw a straight line we need 2 points. So if I choose 0 for X, my X goes away. Okay, I'm going to write it out, but I mean it's sometimes can be just blacking it out, not looking at it, and then solving what's left here. But if I choose 0 for X, I get my 2 times 0 minus 3y is 6, and then y is -2. So if I choose 0 for y, well, the -3y goes away, and I'm left with 2x equals 6. So most of these are one-step equations when you do that. But I will write it out for you. And so x equals 3. So I plot these 2 points, 0, -2. Make sure you plot them correctly. If I had $1 every time somebody plotted intercept backwards, I could retire. 3, 0 is here. And then put your arrows on the ends of your line, because this line goes on forever. Now I can also graph using 1 point and the slope. So for example, if I had this equation I started with here, and I put it in slope-intercept form, so I'm going to solve it for y. I get y is 2/3 x minus 2. Okay, 6 divided by -3 is 2. So 1 point is my y-intercept. So my slope is 2/3. My y-intercept is 0, -2. So I'm going to plot this point at 0, -2. And I'm going to use my rise over run to find a second point. So rise, if it's positive, it's up. +3 down here is right. So up 2, right 3. And it's exactly the 2 points we found intercept way. But, that's just the way this one happened to work. But it's the same line. So you're going to get the same line. It's just 2 different methods to graph it. So what I normally advise is, you choose the method that you like, that works for you the best, but sometimes it depends how the equation's set up. I mean, if my x and y are on the same side of the equal sign and they're both factors of this number, I'm doing it by intercepts because it's quicker. If my equation is in this form already, slope-intercept form, I'm going to use the y-intercept and the slope. Okay, but you got to find out what works for you. You got to find out what works for you. This is a long one. All right, vertical and horizontal lines. So we talked about those earlier. Vertical line is straight up and down. Slope is undefined. Horizontal line goes straight across. Slope is 0. So when I want to graph the equation that says x equals, well, that right there is the format for a vertical line. So sometimes I think to have students maybe not mess this up, when it says x is 3, that means x is always 3 no matter what y is. So just choose your 2 points, 3, 0 and 3, 1, and you'll see that it is a vertical line. And you can do the same thing with the horizontal line. Y is -3. So that means in this case, no matter what x is, y is just -3. Because see, there's nothing to put x in for. So y is just -3. So I can choose really whatever x's I want to. Or just know that it's a horizontal line at y is -3. Okay, so there's no really calculating to do to graph these types of lines. It's just a matter of to make sure you don't get them backwards. That's usually what happens. Okay, all right. So we did slope, we did graphing. Now we're going to look at getting the equation of a line. So each line on a graph comes from an equation. Okay, and what we need to know to get the equation of a line is 1 point, and you got to know the slope. Now, once we have that information, we can use the point-slope form, which is this formula right here. Again, m is your slope. x1 and y1 are the coordinates of the point. Okay, so this is what we use when we want to find the equation of a line. So, if I want to find the equation of a line through this point here with a slope of 4, I'm using this formula, my point-slope form. My x1 is 1, my y1 is 2, my m is 4. So I substitute. So this is your point-slope form right here. Now, it's confusing because the other thing we talked about was slope-intercept form. But this is point-slope form. Slope-intercept form would be to make it y equals. So I get y minus 2 is 4x minus 4. Add 2 to both sides, and I get y is 4x minus 2. So this is slope-intercept form. So there's a difference. Oftentimes, I mean, I like them in slope-intercept form. Now, if you do work at My Labs Plus, or somewhere else, they may ask you to leave it in point-slope form, something else. But this is, I'm fine with slope-intercept form. This really tells me not much. I'd rather have this. Just personal preference. Now, if I want to find an equation of a horizontal line, remember horizontal line is x is a, or excuse me, that's a vertical line, is y is b. And in this case, if y is 2 here, y is always 2. So again, there's not much you can calculate there other than that for these. Now, you could use the point slope form knowing your slope is 0, but this is a little bit, less time. If you can. But if you want to go through the point slope form, it would look something like this. Y minus 2 is 0 times x minus 3. 0 times anything is 0, so I add 2 to get y is 2. So either way, you're fine. Now, if it's a horizontal line or vertical line, you can't use this formula. You got to just know it's x equals. Okay, now let's look at given 2 points. So if I'm given 2 points on the line, I've got to find the slope. I can't get the equation without the slope. Once we find the slope, we can use either point to find the equation. So I'm going to find my slope, and be careful here. Watch your negatives. Negative 4 minus 2 over 1 minus negative 1. 1 minus negative 1. So what this becomes here is negative 1 plus 1, which is negative 6 over 2, which is negative 3. So that's my slope. I can choose either point I want to continue. Just watch your signs here. So I'm going to use my point slope form. So I'm going to use the first point. So y minus 2 is negative 3, and be careful again, you got to watch these signs. Okay, I've got a double negative here, which I'm going to go ahead, before I distribute, I'm going to make that x plus 1. Now, I'm going to distribute. I'm going to add 2, and I get y is negative 3x minus 1. Okay. All right, so just for time purposes, I'm going to skip that next example just because I know I still have, more to do, and I try to keep these videos close under 30 minutes as possible. All right, in this example, I want to find the equation of the line with slope 3, y-intercept negative 2. I'm giving you this example because, you can certainly use the point slope form, because you could say m is 3 and my point is 0, negative 2. Or, since you know the slope and the y-intercept, you can just substitute them into the slope-intercept form, okay? So I don't want to muddy the waters too much, but that just is an option there, okay? But if you are a person that likes to use the same thing every time, then keep using the point slope form, okay? So that pretty much covers 2-3. In 2-4, we look at parallel and perpendicular lines. And what you got to understand is we're going to be working and doing equations of lines and things like that. And we're told they're either parallel or perpendicular, or we have to determine if they're parallel or perpendicular. So parallel lines have the same slope. Perpendicular lines have slopes whose product is negative 1. They're what I call opposite reciprocals. So an example of a parallel line would be these two. They both have the slope as 2, so the lines are parallel. Perpendicular lines, this one has a slope of 2. This one is negative 1/2. So our slope for one line is 2, the other one is negative 1/2. If we multiply those together, if I take 2 times negative 1/2, I get negative 1, that tells us they're perpendicular. So if I want to find an equation of a line that has this point and is parallel to this line. And just for all practical purposes, this form right here is what's called general form. There's all kinds of forms in math. General form is where everything's on one side set equal to 0. But in order to get the equation of the line, I need the slope. Well, I'm going to get the slope from here. So since the lines are parallel, my slope is going to be the same. Now what I've got to do is I'm going to put this thing in slope-intercept form. So I'm going to first subtract 5 from both sides. Subtract 4x from both sides. Then divide everything by 6. And so y is negative 2/3 x minus 5/6. So since it's parallel, I know my slope is negative 2/3. So what I'm going to do is, I'm going to move because I ran out of room. I wrote too big, too far spread out. I'm going to use y minus y1. Let me just go on the back here. And I'm going to use m is negative 2/3. x1 is 5. I'm going to use the point that I'm giving you right here. y1 is 2. Substitute y minus y1 equals m times x minus x1. And that's your equation in point slope form. Okay? You know, that's oftentimes all you're asked to put it in. But again, for me, you know, you may have to go further. So I'm going to distribute. I know we don't like fractions, but it's okay. Negative 5 times negative 2 is positive 10/3. Okay, so let's attack these fractions. Let's just go with it. I'm going to add 2. But if I add 2 here, look how I do that. 2 is 6/3. Because 6/3 is 2, I got to have the same denominators. So y equals negative 2/3 x plus 16/3. Okay, don't fear the fraction. It's really not too bad. Okay. All right, so that's the parallel. That's the parallel. So those lines are parallel. Now, in the last example, we're doing the same equation, and we want to do the line that's perpendicular. So from, again, my slope in this case is going to be 3/2. Okay. The point is this time 4/2. Now the slope is 3/2 because the perpendicular line is going to be the opposite reciprocal of the slope of the original line. So opposite means I'm going to make it positive, flip it over to make it 3/2. So then I do my point slope form. Ooh, this is nice here. 12/2. Add 2 to both sides. So there you go. So there is your line that's perpendicular to this line. Okay. I think, you know, obviously, when you say slopes are the same, that's easier than doing perpendicular slopes where they're opposite reciprocals. But just remember, if they're parallel, the slopes are the same. If they're perpendicular, you take the original slope, change its sign, and do the reciprocal. Okay? So we will cover more of this in class. Have a good rest of the day. And I made it under 30 minutes, barely.